Okay. We know that the degree is 3. So that's our max number of solutions. That's the max number of zeros we're going to get is 3. If I think about Descartes' rule, positive, 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 negative. I have for positive f of x, I only have one change. So that tells me I have one positive solution, one positive 0. If I go to f of negative x, remember it's going to change every time I have an odd exponent. My sign will change. So if I'm looking at f of negative x, come on, okay, come on, computer, come on, internet, then I'm going to have a negative x to the third. This is even, so that's going to stay positive. That's odd, so that's going to change to a negative 11x, and there's no x on the 20, so that stays as a negative 20. So now if I look, I have one change and a second change. So for negative solutions, I have 2 or 0 negative solutions. Whatever they're going to be, one will be positive, 2 or none will be negative. All right, so then I need my P over Q, right? And our last term is our P. And our first term, I'm not going to use this one. That's f of negative x. I need to go back up to P and Q. And this is kind of an easy one because my Q is 1. So that's just going to leave me with the factors of that 20. So I have plus or minus 1, 2, 4, 5, 10, and 20. Those are all of my possible solutions. And I'm going to start with 1. Get some more space here. And test out 1. I'm going to use my factor theorem to test 1 out. So I'm going to do f of 1. So x to the third would be 1 to the third. That's a 1. Plus 8 times 1 squared. That's going to be 8. Plus 11 minus 20. And that is going to give me a 0. So I'm going to move on to synthetic division and divide my polynomial by 1. So that's going to be my coefficients. I've got my exponents in order, 3, 2, 1, 0. So I'm good there. So I'm going to say 1, 8, 11, and negative 20. And I'm dividing by a 1. Bring down my first term. 1 times 1 is 1. Yep, let me hold up a little bit here. Okay. And 8 plus 1 is 9. 9 times 1 is 9. And 11 plus 9 is 20. 20 times 1. All right, so now I have x minus 1, because that's my positive one. Ma'am?
How did you get the 1 to plug in?
So we're using our factors. So these are my possibles, right? All of these are a potential solution that I'm looking for. Hold on for me. All of these here are my potentials. Oh, this drag is going to make me crazy. Wonder. So I'm going to start at 1. And I'm just going to use my factor theorem and I'm going to test. If I get a 0, come on, internet. If I get that 0 when I test out 1, then I know 1 is a solution.
So you basically just doing it for all of them?
Yep, until I get my answer.
Which 3 zeros?
I'm not going to have to do them all. At most, I'm going to have 3. At most, I'll have 3 of them. But for our purposes, for the majority of the time, once you get one of them, you're going to be using your factor skills. So it's not going to be as much as it seems like. So here's my 1 with x minus 1. Then I've got to use what I've got here so I can write my other. That's going to leave me with x squared plus 9x plus 20. And this is what I'm talking about, where most times you are not going to have to go back to the drawing board and work on testing more of them. Because we know how to factor. X squared plus 9x plus 20. What can I multiply that will get me a 20 and add up to that 9? Come on, internet. Catch up. There we go. So there's my solutions. I have factored this polynomial, x to the third plus 8x squared plus 11x minus 20, down to x minus 1, x plus 4, and x plus 5. If I were to FOIL all of these out, I would get right back up to the original polynomial. All right, so my solutions, 1, -4, and -5. Okay. Questions on that one? All right. I'm going to put one more up. And this is your problem 50 out of your textbook. So again, we know that we have 3 maximum solutions. If I look This is my f of x, my positive x. I have one change. So I have one positive solution. If I go for f of negative x, I'm going to have a negative 3x to the third. 2 is even, so that's going to stay a positive 6x squared. 1 is odd, so that's going to become a positive 15x minus 30. Now my number of changes. I go from negative to positive, stay positive, back to negative. So for f of negative x, I have 2 or 0 negative solutions. Total possible solutions. That's why I picked this one out. What do you see about every term on there? Just something that we always want to be aware of. 3, 6, 15, and 30. Aren't all of them divisible by a 3? I'm going to rewrite that. I'm going to simplify that down to x to the third plus 2x squared minus 5x minus 10. I'm going to take out that 3. Since it's divisible, since everybody in there is divisible by 3, I'm going to make my numbers a little bit smaller. Now my P is 10. My Q is 1. So for testing for all my potential possible, oh, this is going to make me crazy. Come on. Are you guys having as much drag as I mean, I see x to the third plus 2.
It's the same.
Okay. All right, finally. All right, so P is 10 and Q is 1. So for my potential, all I have to worry about, since Q is 1, is my factors of 10. So that's going to be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Again, I'm just going to start with the 1 since I want to start with what's easiest. If I do 1 to the third plus 2 times 1 squared minus 5 times 1 minus 10. There's no way I'm getting a 0 there. So I'm going to take that guy out. If I do negative 1, then I'm going to have negative 1 to the third plus 2 times negative 1 squared minus 5 times negative 1 minus 10. So that's going to give me negative 1 plus 2 plus 5 minus 10. That's not going to end up with a 0. So I've got to move on and try another one. And I'm going to move to negative 2. So if I have negative 2 to the third plus 2 times negative 2 squared minus 5 times negative 2 minus 10. And right here, just doing some math in my head, that's where that negative 5 and negative 2 getting canceled by that 10 kind of, there's clues that'll help you to pick numbers. So this is going to be a negative 8. Negative 2 squared is a positive 4 times 2 is a positive 8 plus 10 minus 10. All right, so there's my 0. So I know negative 2 is a solution, right? I have negative 2, I have 2 or 0 negative solutions. So I know now that negative 2 is one solution. So I'm going into my synthetic division. I'm going to be dividing by negative 2. My coefficients 1, 2, negative 5, and negative 10. I'm going to bring down that 1. And 1 times negative 2 is negative 2. 0. 0 is negative 5. And 10 is 0. So what I have for an answer right now is x plus 2. Remember, that's a negative 2. In here, it's going to be a positive 2. Times, I've got this 0 here, so I have x squared minus 5. Now that's a quadratic. So I'm going to factor x squared minus 5 down to x plus 2 times x plus the square root of 5 and x minus the square root of 5. And that's my solutions. Negative 2, negative square root of 5, and positive square root of 5. Questions on that one, guys? All right, 5.3. What are we going to talk about in 5.3? First off, we're going to talk about domain. Now remember, your domain is where your x does not equal 0. You can't have a 0 down here. So that's where we're going to have to find out. And you've done these problems before. If I'm asking you, if this is f of x, and I say, give me the domain, you're going to be telling me basically that what the domain is not. This is where you have to say x minus 7 equals 0 and solve, and you're going to have the domain is equal to the set of x such that x does not equal 7. On this, on 18, you're going to do them both. I only wanted to do 18 because this guy right here, that 4 minus x, tends to make a problem. X plus 3 gives you a negative 3, but 4 minus x is going to give you a positive 4. Be careful, like you'd be adding the x to both sides. So my domain is going to be the set of x such that x does not equal a negative 3 and x does not equal a 4. All right, what do you do on these where you have the full quadratic? You're going to have to factor, okay? Factor it out. Maybe something will cancel, maybe it won't. Right now, we're going to look for something that will multiply. 2 times negative 12 is negative 24, and negative 5. So what will multiply to a negative 24, but add to a negative 5? So I'm going to factor this. I've got 3x times x minus 1. Come on. And 2x squared minus or plus 3x minus 8x minus 12. Get into the grouping. And from 2x squared plus 3x, I'm going to pull out an x. And that's going to leave me with 2x plus 3. From negative 8x minus 12, I'm going to pull out a negative 4. And that's going to, again, leave me with 2x plus 3. So for 20, I have 3x over x minus 1 over x minus 4 and 2x plus 3. So my domain is going to be the set of x such that x does not equal 4 and x does not equal a negative 2/3. Come on, internet. Now, be careful. One of the reasons why you want to factor, I'm not going to do 26 on this one since the drag is so bad. I'm going to get on into asymptotes. But when I factor on 26, you always want to watch sometimes when you get it factored that it is going to reduce. So that x plus 2 shows up in both the numerator and the denominator, so it's going to cancel itself out. I know you did that factoring of rational equations in Algebra 1. All right, so I'm going to talk about asymptotes here. Let me move over, if I can get... What is an asymptote? If you look, take these off. So we're graphing the equation y equals 3x times x minus 1 and y equals or over 2x. Come on. And that's what this graph looks like. The asymptote is these lines where it'll never touch. The asymptote on this one is going to be where we factored that just a little while ago, where we factored 2x squared minus 5x minus 12. And we got the x equal to 4 and the x equal to a negative 3/2. Come on, internet. This line and this line, even though it looks like my graph is touching it, it'll get infinitely closer, but it's never actually going to be touching. Those lines are what we're looking for when we're talking about asymptotes. These lines on our graph, where our graph will get infinitely close to, but they will never actually touch. If I look at six over x, come on, 6 over x plus 3 times 4 minus x. Here we're going to have that same line at the x equals 4 and the x equals negative 3. Those are the lines that we're looking for when we're looking for these asymptotes. So for the vertical, again, it's going to be where that x equals 0. So if I have, let's say, I'm looking for the problems that I pulled. Let's say I have 3x plus 5 over x minus 6. My vertical is going to be at x is equal to 6. It's the same situation as when I was looking for the domain. It's just going to be wherever that x would get a 0 in the denominator, that's where my graph would break. Come on, refresh. Now, when it comes to the horizontal, there's 3 situations. I've got to look at the degree of the polynomial. If I have a rational equation and the degree in the numerator and in the denominator are equal, whatever that coefficient is, that's going to be my horizontal asymptote. Now, if the degree in the numerator is greater than the degree in the denominator, then you're going to say there is no horizontal asymptote. Come on. And if you flip it around and the numerator is less than, then it's always going to be y equals 0. So let's say I have we're going to start with, this is your problem 48. I have x to the third plus 1 over x squared minus 5x minus 14. I'm going to factor them both. When you do x to the third plus 1, that's the sum of cubes. You've got x plus 1 times x squared minus x plus 1. And then what could I multiply to get a negative 14 that would add to a negative 5? And that's going to be x minus 7 and x plus 2. So now I'm looking, does any of this, come on, does any of this reduce? No, I have an x plus 1, x minus 7, x plus 2. Nothing's going to reduce. I always check it because it's a if-then situation. Sometimes it will, sometimes it won't. My vertical from here, I'm going to have a vertical asymptote at x equals 7. And from my second, I'm going to have another vertical asymptote at x equals negative 2. For my horizontal, my degree in the numerator is cubed, in the denominator is squared, so my numerator is greater than my denominator, so I will have no horizontal asymptote. How are we doing, guys? All right. We'll get these videos up. If anybody does not have any, if everybody does not have any questions, I'm going to let y'all go since this drag is making everybody crazy. And we'll look at some more videos. I am not going to include (5.4) in the upcoming test. It'll be 5.1, 2, 6, and the review 6. Okay? And again, I'm going to put that'll open Monday night. This test you will be taking online. This Monday, we'll do the study guide, and Wednesday, we will be working on our chapter 6. Deja, you have a question?
Oh, never mind. It popped up on the screen. I was going to ask you to repeat the numbers, but they popped up on my screen.
Okay. All right. It's just really bad drag.
Is 4, 3, and 4, is the chapter 4 going to be on the test?
Yes. This is just from chapter
Okay,
5. 4, 3, and 4, 5.
4, 3, and 4,
4.5.
Now you have your chapter 5 quiz is in your Canvas.
Okay, and about the math labs, which ones are due?
The 5 and the review, I'm going to unassign the 5-4.
And was 5-7 on the one from Monday, the video from Monday?
No, 5-7 was never in.
On my math lab, it says 5-7 is included in the thing. So I was just wondering.
Okay, no, I'll take that out. 5-7's
like,
never been in there. Shouldn't be in there.
5-6 and 5-7 are part of the same assignment on Math Lab. Like they have the same 10 questions.
All right. Let me go in and look at the questions and make sure, because it's going to be just the ones with negative radicals in 5-7. I'm not. You shouldn't have any questions on that.
Are we going to be testing on the theorem for bounds on zeros? Okay.
No, just what we've talked about in class. Let's see, it's only 6:38. You're good to go if you're good to go, but I'm going to stay on if anybody has any questions or would like to practice on anything, okay?
May you go over how you know about the positive and the negative sign change?
Descartes? Okay.
Yes, ma'am.
So when you are doing that, you're going to do f of x and then you're going to do f of negative x. You're going to replace all of, come on, internet. You're going to replace all of your x's with a negative x. And the only time that's going to change your signs, what are you doing? Come on, this doesn't want to go back to. It does not want to go back to my writing tablet here. Come on.
Hey, Miss White, I was making sure
Mhm.
the test is gonna be on Monday.
I'm going to open the test on Monday. Test will be online. And when I get out of class, after class on Monday, I'll